So I'll be doing this on the Google Cloud platform. And if I go through this infrastructure quickly, in the tools deployment manager, you can see that I have already F5 deployed. It's up and running. It's the best bundle. And if I go to the compute, to the Kubernetes engine, I have also a cluster that it's running and consists of 2 nodes. As I said, we covered these details, how to create the cluster, how to create big IP in a previous video. So you can go back to that video and watch it. And eventually all of these, both F5 and the Kubernetes cluster nodes, they will be running as a virtual machines under the compute engine. So you can see this VM is the F5 and the other 2 is the Kubernetes nodes. Each have an internal IP and external IP. Okay, so now let me let me go inside the cluster. And first you can see that the cluster have 2 healthy nodes. I do not have anything run there, so there is no pods, no containers running. So let me run my first application. I'm gonna run an Apache service or Apache web server inside my cluster. So I'll say Kubernetes create deployment. I will call it HTTPD, and I will use the image of HTTPD version 2.4. So this is Apache 2.4. Show it's created. So let me get the deployment information. You can see it's up and running, and it should have 1 pod that's created, and it's also marked as running. Okay, now this pod, of course, it's using an internal IP inside the cluster. So the next step, I need to expose this container to be accessed from outside the cluster, so F5 can manage it eventually. So to do that, I will just expose this deployment that have HTTPD name, and it will be exposed on the port 80, and the type of this service will be node port. So what this means is that on every single node in this cluster, that service will be listening on the node port, and that port I can get it by getting the service, and I can see here the service created with this port. In the F5, I have a pool member already configured. I'm not using container connector in this demo. So if I go to the pool, I can see the HTTPD service, which have 2 members. These 2 IPs are the Kubernetes cluster IP. I can verify this quickly. So here is the 2 IPs, and I'm listening on this service. So basically, the Kubernetes created a random port. I need to change it. So I'll just go edit the service. I will go to the node port line. I will make this 380 to match what I have on big IP. And I can double check this again. It reflects now the IP. It should mark those as green now. And I can also connect to it by trying to access any of these node IPs. So I can just say curl and on this port 380, and that show me it works. That's fine. I can connect to it from the browser also. It should say it work. And most importantly, the F5 virtual server is the single NIC interface. So if I go to this IP of the virtual server in the F5, it show it work. It's listening on port 80. Good. So now let me try to launch the attack and see what is the impact. But before I launch the attack, I want to do a couple of changes to my service. First, I want to allocate resource limit on my service, which is a common best practice that containers get specific amount of memory to avoid containers that consuming the resources of the servers and have a bad impact on the other containers. The other thing I also need to do is to apply some health monitorings on the container so I can see when there is a bad impact or bad health of the container. And to do that, I will also quickly edit my deployment, and this should take me to the manifest file, YAML file of this deployment. You can see here the resources are null. There is no resources. This is the default, but it's best practice to assign resources. So I will put limits, and the limits will be memory, and I will give this container 50 megabyte. Okay, so if it tries to exceed this 50 megabyte, it will basically be restarted or it will be evicted, and this is to protect the cluster. The other thing I want to do is also to assign health monitors, and this is something that I will just copy quickly from here to save time. So I will go under the containers. So here is the container, and I will say for this container apply this health monitor through the liveness probe. And what this will do, as you see, it will send an HTTP GET request to this path, which is the default path of the website on a port 80. Okay, and it will give a 3 seconds at beginning as a delay until that container basically run. So it will take until the container basically run. I'm not gonna run the health for 3 seconds, and then I will keep running this health check every 3 seconds. Let me apply this. Fine. Now I can see that I got. So Kubernetes is terminating the older pod. It's creating a new one which reflects the new settings that I have applied. There you go, and everything still working fine. So now let me launch the attack. I'm gonna launch a slow low-risk attack, which is a common HTTP attack, and I'll also launch a slow post attack. And I want, while I'm running the attack, you keep an eye on the pod restarts. Okay, so launch this attack and also launch the slow post attack. So I'm launching slow low-risk here and slow post in another tab, and these will keep sending those packets to my application. And we will monitor it here. So you can see the attack have some drops. It works sometimes and it doesn't work sometimes. This is because it's keep restarting. So we'll give it a few times and I will come back. I will fast forward the video and I will come back after a couple of few restarts. Okay, so you can see the application is fully down, and it reached to the point where it's show me crash loop back off, and this is the status where the containers kept crashing for in a high frequency in a short amount of time. So it will stay in this status for some time before it's getting restarted again. And as you can see, it's down now. So I'll close this, and before I apply the protection, I can imagine someone would think that, okay, maybe another idea is to increase the number of the pods or the containers, which is actually a good idea. So and let's do that. But first, let me delete this pod to get replaced by a new one that show 0 restarts. And I will also scale this. So I will say Kubernetes scale the deployment HTTPD to replicas. Let's make it 3. So I'm gonna scale my deployment to 3 pods. And let's launch the attack again and see if that will make difference. So now instead of having 1 container, I have 3 containers which the loads are distributed on all of the 3. So let me launch the attack again and see if that make any difference. Okay, so as you can see, the attacks are still happening, the containers are still crashing, and it didn't make change. Even if I increase the number of the containers, they will eventually fail and restart again. I can also describe one of them to see more details about what was going on exactly. And you see here that it was killing the container because it failed with the liveness probe. So there was timeout value for those containers in the responding to the requests. So now let me stop the attacks and go apply the F5 security policy on the virtual server. So I'll switch this to a full proxy HTTP, and next I will apply the WAF policy, which is the Web Application Firewall security policy, and let me scale the application down to 1 pod again, and let me delete it to get a new brand new with the restarts 0. And the Kubernetes deployment will automatically restart it through the replica sets, bringing me a new one. So let me now watch it, and I want you to watch again the restarts, and I will go back to run the same attacks. And let's see if that will make difference after applying the application security policies on the F5. So we'll keep it running for some time, and I will be fast forwarding the video. Okay, so I kept the attack running for a few minutes, and as you can see, there is no single restart. We can look at the pod, and it should show that it's been running since like 4 minutes with the attack continuous during that time with a 0 restart. And this is because we applied the application security policy on the F5 for this application, which prevented these type of attacks. So with that, thank you for watching.